We are looking at November of 2004, 27.82 grams of hydrated sodium carbonate crystals. Now, some of you, this might be first time that you see a molecular formula that has .xH2O in it. These are known as hydrated salt or desiccants. They're used to capture moisture, and they still stay as solid while they have trapped moisture within their crystalline structure. So for every 1 mole Na2CO3, you have X moles of H2O. Usually in a typical question like this, you have to find value of X. So 27.82 grams of this was dissolved in 1 decimeter cube of water or solution. And from that batch, 25 centimeter cube was used to neutralize hydrochloric acid of this volume and this given concentration. Write an equation for the reaction between sodium carbonate. Note they didn't say hydrated sodium carbonate, so the formula is given to you. So it's an easy equation to write. Na2CO3 plus, hopefully you know what hydrochloric acid is, HCl. Then you produce salt, NaCl, plus a weak acid of H2CO3 that decomposes immediately into water and CO2. IB prefers if you write H2O plus CO2 rather than H2CO3. Now you have 2 sodium, so you put 2 NaCl. You have 2 hydrogens, 2 Cl, so it makes sense to have 2 HCl. You get 1 point for the equation, 1 point for the balanced equation. Now the second part, B part, is calculate molar concentration of sodium carbonate neutralized. First, you have to find moles of hydrochloric acid, then moles of Na2CO3, and then divide it by its volume, and you have the concentration. So let's go after moles of HCl first. Moles of HCl is nothing but concentration times volume. Concentration is 0.100 mole per dm cube. Volume that you used was 48.8 centimeter cube converted to decimeter cube. When you do this, your final answer with 4 significant figures will be 0.00480 moles of HCl. Now, note zeros to the left are not significant, zeros to the right are significant. So I have 1, 2, 3, 4 significant figures at this stage. So the next part, so I get 1 point out of 3 so far. I go after moles of Na2CO3. Many of you see the ratio is 2 to 1, so you simply divide this number by 2. If you don't mind, I'm just going to work it out. So it's 0.00488 moles of HCl that was neutralized times, from balanced equation, for every 2 moles of HCl, I use 1 mole of Na2CO3. So this becomes 0.00244 moles of Na2CO3. I get my second point. Now concentration is simply moles divided by volume. So you go after 0.00244 moles. What volume? You used only 25 centimeter cubes, so 0.025 decimeter cube. This is the volume I used. And if you stop here, you will find your concentration, which is 0.0976 moles per dm cube. And this part of the problem is solved. You get your third point. Now determine the mass of sodium carbonate neutralized by hydrochloric acid, and then mass of sodium carbonate in your 1 decimeter cube solution. So let's see what's the mass. Mass is simply moles times molar mass. Now the moles of sodium carbonate is 0.00244 moles. Molar mass of sodium carbonate, you have 2 sodium, 1 carbon, and 3 oxygen, which is 105.99 grams per mole. If you do the calculation, you get 0.259 grams of Na2CO3 in 25 centimeter cube. I write that because the problem still is not solved. Next part is how much do you really have in 1 decimeter cube of sample. So I'm going to look at a cross multiplying ratio. I have 0.259 grams in every 25 centimeter cube, or 0.025 decimeter cube. How much should I really have in 1 decimeter cube? And that will be your actual answer for the amount that you have in 1 decimeter cube, which is 10.36 grams of Na2CO3. Okay, now have this number. We go to the next page, so it continues. Let's just see what's the next question. First thing is calculate mass of water in the hydrated crystals and hence find the value of X. And I think this was a 3-pointer here. I forgot to write. So let's see what is mass of, remember first part of the question, or go back to the next last page. You had 27.82 grams of hydrated salt. And on the last sort of problem, we calculated that we have 10.36 grams of just Na2CO3. If you subtract these two numbers, you find grams of water that was used, which is 17.46 grams of H2O. Now, this is like empirical molecular formula question, except you have a rather two molecules in each other. For this, you have 10.36 grams, and for water you have 17.46 grams. Now what I'm going to do is divide by their molar mass to find moles, and then I'm going to divide by the smallest, and hopefully X comes to life. So molar mass of sodium carbonate was 105.99 grams per mole. Molar mass of water is 18.02 grams per mole. The first division will give me 0.0976. The second one will give me 0.9689. Then divide by the smallest of the two numbers, which is 0.0976. 0.0976. This is 1 mole, and this is 10, and X is 10. So it's Na2CO3 10H2O. This was X.